As a final student majoring in computer forensic, I was assigned to perform a forensic analysis of the digital evidence collected in this case. The primary objective of this investigation is to trace the digital footprint of this unauthorized access and to ensure that the activity can be proven through admissible digital evidence. This report covers analysis using reliable digital forensic tools and demonstrates good ethical practice throughout the investigation process. When we received the evidence in the form of a USB drive, the first step was to ensure that all digital evidence was handled properly to maintain its integrity and admissibility. The following items were included in our initial response kit. Okay, first, USB drive to store forensic copies of evidence from the original storage device. Second, write blocker to prevent any accidental modification of the original storage media. Third, FTK imager to load, examine, and extract data from forensic image file. Fourth, Wireshark to inspect and analyze the network capture file containing network traffic activity. And lastly, Notepad to open and read text file containing relevant information such as password. By using this tool, we ensure that every step of the investigation was carried out with full integrity and without altering the original evidence. Okay, next, forensic image analysis using FTK image. The first step in this investigation was to analyze the forensic image file extract from the suspect USB drive. The image file, Hacker Pendrive E01, was loaded into FTK Imager, a trusted forensic analysis tool. The process was as follows. First, I open FTK Imager, then select Add Evidence item and choose the evidence type image file since the file provided was in E01 format. Next, the image file was loaded, allowing us to examine partition, file structure, and important metadata. After loading the image, I discovered several suspicious files for the further examination. One notable file was USB owner detail TAT, which indicate that the USB device likely belonged to Kamil Hamirin, a student from the Department of Information Technology. I then performed the following steps. First, I right-click on the file and select Export File to save it into the Evidence folder. Next, I open the file to clearly view its content information linking the device to the suspect and hint of suspicious activity. This finding is critical because it confirms the association between Kamil Hamirin and the USB drive, which may have been used to access the IPO account without authorization. I also uncovered another document named USB owner detail TAT that contains chat-like message related to unauthorized access activity. By opening this file in Notepad, I found referencing IPO login details. This conversation had established intent, identity, or connection of the suspect to incident where we carefully examine any username, date, or phrase related to the IPO portal. Report, I have traced the digital evidence linking Kamil Hamirin to the unauthorized access of an IPO account using forensic image and chat log analysis. The key finding confirmed the suspect involvement. As a recommendation, it is crucial to strengthen account security by implementing two-factor authentication and upgrade security protocol to prevent similar incidents in the future.
In this step, we use Wireshark to analyze the network traffic file named IPO password word sample.pca.png found on the USB. Our main goal was to detect any sign of unauthorized activity such as leaked credentials. To do this efficiently, we use Wireshark filter feature. First, we apply a keyword filter like password to search for any packets that might contain login credentials or other sensitive data. Next, we refine our search by typing HTTP into the filter bar. This allows us to focus only on unsecured HTTP packets. These are important because they often carry unencrypted data such as usernames and password entered into website. By narrowing down the traffic to only HTTP communication, we could isolate and inspect potential data leaks or malicious activity more effectively. In this analysis, we capture network traffic using Wireshark. While reviewing the packets, we found a suspicious HTTP post request. This type of request usually happens when someone tries to log into a website. In this case, the IPO system. To investigate feature, we right-click on the post packet. Then, we selected follow TCP stream. This allows us to see the full communication between the user browser and the server. When the TCP stream opened, we saw the raw HTTP data. Since the communication was not encrypted, we could clearly see the username and password that the user submitted through the login form. This image shows a TCP stream capture in Wireshark, where a login request was sent to the IPO website using an insecure HTTP connection. The highlighted section reveals sensitive information, specifically a username and password in plain text. Because HTTP does not encrypt data, any user on the same shared network could potentially intercept this information. The PCA.png file, which contains this data, was found on a USB drive belonging to Kamil Hamarin. This strongly indicates that the device may have been used to capture another student's login credentials without their knowledge. It raises serious concern about privacy security and ethical behavior in a shared network environment. That's all from me. Thank you.
Okay, Assalamualaikum and hi, my name is Huda Fasana and my matrix number are 01DDT23F1185. So right now I will explain about verifying the USB evidence with FTK Imager. In this stage of the investigation, we use a forensic tool called FTK Imager to create an exact copy of the USB driver used investigation. This process is important because it allows us to work on a duplicate version of the data rather than the original, ensuring that the original evidence remain untouched and unchanged. Okay, after the forensic image was created, we needed to verify that it was identical to the original. To do this, we use MD5 and SHA1 hash values. This hash function like digital fingerprints. If the hash value of the copy match the hash of the original, it confirms that no data was altered during the copying process. In this case, both the MD5 and SH1 values match perfectly. This verified that the image was created accurately, with all files remaining intact and in their original directory structure. The verification process ensures the integrity and authenticity of the copy evidence. Next, throughout the entire investigation, we follow important ethical guidelines and professional standards to ensure the investigation was valid and trustworthy. Firstly, we maintain the integrity of evidence by only working on copies of the original files. The original E01 image and PCAP-NG file were never modified during the analysis. This ensures that the real evidence stay intact. Secondly, we respect confidentiality. We avoided accessing any files that were unrelated to the case, ensuring that private or sensitive information remain undisclosed. Thirdly, we documented every step of the process to maintain the chain of custody. This means we recorded exactly how the evidence was handled from the beginning to the end. Okay, lastly, the tools and the method used during the investigation complete with legal standards. We ensure that everything follows proper digital forensic procedure. We ensure that everything follow proper digital forensic procedure that are widely accepted in the field. By adhering to these 4 key principles: integrity, confidentiality, chain of custody, and legal compliance, we upheld professionalism and ethical responsibility throughout the investigation. Conclusion: based on the evidence obtained from the both FTK imager and Wireshark analysis, it is concluded that the USB drive under investigation belongs to Kamil Hamarina, student from JTMK. Second, the USB contained a network packet capture file which revealed the login credentials of another student's IPO account. These credentials were transmitted over an insecure HTTP connection, which were likely intercepted using network sniffing techniques. This finding clearly indicates that unauthorized access to the IPO system occurred, and that the USB drive may have played a role in facilitating this access. Okay, that's all from us. Thank you.